so in 13a, we're asked to determine the solution to each system if it exists. So the first thing we kind of want to look for is there a solution? Are there any obvious parallel or coincident planes going on here? So I look for my scalar multiples and I don't see any right off the bat. There's no relationship between equation 1, equation 2, equation 3. So the next thing I want to look for is linear combinations. Could I add or subtract 1 and 2 to get 3, or 2 and 3 to get 4? And again, I don't notice anything obvious right off the bat, in particular because there's no x's in the last equation. That kind of throws that idea out. So the fact that I don't see any linear combinations suggests to me that this is going to meet at a point. So if it meets at a point, that means I can use double elimination to solve it. So let's give it a try. Let's take the first two equations. So 2x minus y minus z, just rewriting them here, okay? X plus y plus 0z, so I don't have to show it if I don't want to, equals 7. And because the y's are opposite signs, let's add them. We've got 3 x's, no y's, minus z, because we're adding with this 0 right here, right? And 17. That's as far as we can go with that one. Let's take another pair of equations. So I'm going to take the second one, x plus y plus no z equals 7. And I'll use the third one also, which is y minus z equals 8. Notice I just have spaces. I don't have to put the zeros if I don't want to. Again, my y's are matched up already, so I can subtract them this time because they have the same signs. I'll end up with an x, no y's. Here's a little trick again. Maybe it helps with the zero this time. 0z minus negative z actually makes a plus z. Just be careful with that one there, okay? And 7 minus 8 is negative 1. Okay, double elimination. I'm going to take this equation right underneath. 3x minus z equals 17. My z's are opposite signs, so let's add. We'll get 4x equals 16, so x must be 4. Once I know x, let's go back and figure out a y. If you notice, equation number 2, actually let's go back and figure out a z first. I'm going to do that. X plus z equals negative 1. We got 4 plus z is negative 1. So z will be negative 5. Now let's go back and get the y. And as I was saying, if you notice equation number 2, which is x plus y equals 7, doesn't even have a z involved in it, right? Put the 4 right in. So 4 plus y is 7, so y is 3. So yes, indeed, there is a POI, a single point. It's 4, 3, and negative 5. And if you wanted to check it, you could. You can just put each of those values into each of the three equations and prove left side equals right side. Okay?